oscillations of a string depends on its mass, length, and tension as follows. So this is the equation for the frequency in which the tension, length, and mass are given. C is a dimensionless quantity. When it says dimensionless quantities means that it has no units, okay? And then find the values of the constant A, B, and C, which appears as the power of the dimensions which are given there. So let me write this here. You have frequency, it is C, P power A, M power B, and then the L power C. Since the mass and the length, both of them are given in their corresponding dimensions, like with the symbol we have described here. For the mass, you have M, and for the length, you have L. So it is already in those symbols. I don't need to do anything with it. But here for the tension, since the unit is only given to us, so therefore I'm dropping the C because it's a unitless quantity. I don't need to deal with it. I'm just concerned about the units. So here you have kilogram, and here for this you have meter, and then per second square. The power of the total will be the same power as the power of P, and here power of L is C again. Now, in the next step, what I want to do is that you have kilogram, you have meter, and you have seconds. Just replace them by their corresponding symbols. So you see that the kilogram, I can replace this by M. M, I can replace this by L. And S, I can replace this by T. And the power of the entire section is again A. Okay? B and L, C. So from now, you can easily see that where I'm heading. So I will just eliminate the top part so that I can write the rest of the equation here, beginning from here. You know that we have M here, and the power of M is A, and here we again have another M, and the power of that M is B. On the left side, I had the frequency, and the unit of frequency is 1/2, right? So that can be written as 1/T. So M, when the bases are the same, the power you can add. So therefore, A plus B. The power of M is A plus B. How much is the power of L? It is A plus C. And then how much is the power of T? Well, you can easily see that it is 2 times A, which will be 2A. Now, look at the two sides of the equation now. What you are seeing is, here you have T and here you have T. So therefore, when I mentioned before that when you have an equation, the left side unit and the right side unit supposed to have the same units. The quantity is supposed to have the same units. Otherwise, the equation will be completely invalid. Okay? So if we want to this equation to have the same units, it would mean that the 2A, which is here, it is equal to 1, because the power of T, which is 2A, and the power of A here is 1. So we compared these two, and we brought it here. 2A is equal to 1. From this, I'm dividing both sides by 2. I will be getting A equal to half, 1/2. This is the value of A I'm getting. Now, the next step. M, the power of that is A plus B. I have the M on the right side of the equation, but I don't have M on the left side of the equation. So therefore, the power of M, A plus B, supposed to be 0, because on the left side it is 0. So from there, I see that the B is equal to -1 when I subtract the A from both sides. And now I'm putting the value of A here. So the B is equal to -1/2. So this is the second equation I have. Okay. Now in the same way, I'm proceeding for the L, and it is A plus C equal to 0. So C equal to minus A, and it is also giving me C equal to minus 1 divided by 2. So now we have all three values. We determined the values of A, B, and C, and that's what you are having here. Okay. Any question here?
Doctor.
Yeah.
Is the lecture recorded or no?
Probably someone already put recording, right? I did. I think someone did it.
Okay, so this question we will see it in the record, right? It
You
should
can
be.
see it in the record, or also I have shared these slides on the Blackboard. You can download these slides from the Blackboard as well.
Doctor,
Yeah.
why did you delete C?
Why I delete C?
Yes.
Because that says that the C is dimensionless quantity. So it's a dimensionless constant, means the dimensions of this is 0. Like it is just like multiplying something with 2, right? So as long as it has no dimensions, I don't need them in the unit, or also I don't need them in the terms of the dimension analysis. Yeah.
Okay. So, Doctor, it will be mentioned in the question, it C is dimensionless or not?
Yeah, if they meant by that, like as they are clearly saying here, C was mentioned there, but they are saying it is dimension analysis. So this question, in a way, it's a very complete question because it covers all parts of it. If something is dimensionless, you don't need to consider that in the dimension analysis, because like as I'm having 2 kilogram of something, and then I multiply it with the number 2, I will get in total 4 kilogram. Okay, so 4 is just the quantity which has changed, but the unit remain the same. As compared to that, if you have 2 kilogram and then you multiply that again with the 2 more kilograms, then what you will have, 2 times 2, which is 4, and kilogram times kilogram, it will be kilogram square, right? So you need to look at those kind of things when you are doing dimension analysis.
Doctor,
Yeah.
I didn't understand why you write 1 over t squared.
1 over t square?
Yes.
Yeah, because here you see that in the dimension analysis, like in this P, you have per second square, right? Like
Yes.
this is per second square. So therefore, the dimensions, if you go to the previous slide, you're seeing that the dimensions of this is for the time. If we have a second unit, the dimension representation for that will be t. So that's why I did it. All right. So let me take the attendance here, and then we begin the next chapter. Okay. So when I send this link in the chat box, so wait a little bit until I tell you to begin your. Let me see. Just wait for that. I myself need to go and activate your form. Okay, so here you have. Okay, so now you can go click on the link and then record your attendance. What you will see, there will be the present button. Click there and submit your answer. That's all. Do it now.
Doctor, for other lectures, for the people who just registered the class, would they be considered absent?
We can talk about that. Just do this now.
Okay.
Is it okay? Did you guys submit your response?
Yes.
Anyone
Yes.
remaining?
Yes.
I'll do it now.
Yeah.
1 minute.
I just did it. Thank you.
Okay. If anyone remaining, let me know. Otherwise, I'm closing the response. Okay. So response closed now. Okay. Let me
Professor,
yeah.
I tried to fill it, but I couldn't. It said it was.
I can open that for you later.
Okay.
Let's begin this second chapter. Here we have this second chapter in which we will be discussing motion along a straight line. It is important to know that we are discussing motion, and the motion is only in the straight line. Okay, so these details are extremely important to know, because if something is happening in the curve, like the motion is happening in the curve, then there will be rotational motion, and then those are the kind of motions which we are not covering at this point. So we will be covering the kinds of motion which are just happening in the straight line. So when an object changes its position with respect to its environment, the object is said to be in motion, right? For example, you are seeing me when I'm walking towards this door, then with respect to this background, I'm changing my position. That's why you can tell that the object are moving. So if you are, let's say you are sitting in a car with your friends, and all the friends are in, like, let's say 4 friends, they are sitting in a car, they're going. So even though the car and the people inside the car, they are moving with respect to the outside environment, but these people are stationary with respect to each other. They are at rest, right? So those guys are not changing the position with respect to each other. Like in the same way now, you might be sitting next to your computer. So you and your computer are at rest with respect to each other. But if you started to move, walk away, then with respect to the computer, you are moving. Okay, so that's how the language we will be using. We will be putting a reference to that. So the kind of motion here we will be discussing, it will be kinematics. So the kinematics are the kind of motion in which we are don't talk about the force at all. Like what kind of force is causing the motion, that is not our concern now. When we talk about the force, this will be called dynamics. Okay, so dynamics we are not considering. We are considering kinematics. So kinematics, it means that we will be saying the object is changing its position. Also, we will be saying the object has covered this much distance in this much time, which will be the speed. Those kind of language we should be using. But we will be not saying that this object was pushed by this force from here. That's something which are not making here. We find moving objects all around us. For example, a car moves around on a road, or Earth orbits around sun. Or electrons and an atom moves around nucleus. All these are different kinds of motion at different scale. Okay, some macroscopic scale, some nanoscopic, or the microscopic scales. Motion, before we again go to the depth of this chapter, there are 3 main concerns, 3 points which I want to emphasize. First of all, strictly speaking, we will be talking about the motion that are happening in the straight line. And I tell you why. Second, in this chapter, we will discuss only the kind of motions and which are happening in straight line, and we will be talking about the motions in a kind of language in which we will be not making any reference to the force. So the force will not be mentioned at all. Okay. And the last point, we will be talking about the rigid objects. So you know that what is the rigid object. Here you have the rigid object. This is a marker, for example, it is a rigid object. Rigid object means that if I'm moving this, all parts of this are going in the same direction and it will cover the same amount of distance. Okay? So as compared to this, if I'm having a page in my hand, a piece of paper, and if I'm moving that, you will be seeing that some part of the piece of the paper will be left behind.
I was in the bathroom and I couldn't attend the class. I couldn't click the link.
Okay.
It's
so
3 minutes ago.
I'm recording you. Okay.
Okay.
Okay. So this is the first time answered. I will give you an excuse today, but not any time more. Okay.
Thank you.
So there is a, let's say this is the object, which is, I said that this marker is a rigid object. So it means that if I'm pushing either from behind or from the front, the entire object will move. As compared to that, this head is not a rigid object. If I'm moving this, you see, if I'm moving them, some part of them are going in the forward direction while some parts are remaining in the backward direction. So this is not considered a rigid object, it's a soft object. So another thing is, I will be considering the rigid object, but the rigid object should be considered as a point object. And here is another point. The point object means that we will be not considering the shape of the object. Like here, the marker is an extended object. And if I'm rotating it around this point, even though it goes forward, it's a rigid, but still it is rotating. So by point object, I would mean I'm eliminating the rotational motion about its center as well. So these are technical points we need to understand. After that, we will be getting into a little bit lighter sections. Two things I want to make in terms of the language that we'll be using in the physics. One is the position, another one is the displacement. So position is the location of the object with respect to an origin. Like I'm standing here with respect to this computer. So the reference point for me for now for the purpose of this class is the camera. So with respect to that camera, I'm here. So my position is about 1 meter away from the camera. So this is my position. But what is displacement? Displacement is a directional quantity. It is the shortest distance between me and the camera. Okay? So between me and the camera, if I want to access the camera, I can go straight to the camera like this as my finger is going, right? But I can also go in this way, like moving this way, wiggling past, and then I can reach out to the camera. So the shortest distance between me and the camera, that is called displacement, not any other path. There will be multiple paths, like from me and the camera, there will be infinite ways to approach to it, but those are not considered displacements. Here is an example. If you want to have the reference point, which is point A, and there is another point B, you move from point A to point B. When you are looking between the 2 points, and that distance is the shortest possible distance, that will be called displacement. But all other references, like when you are making them, for example, these are, I just lost my cursor, I need to get it. Like between point A and point B, the shortest distance is this straight path. So this is the displacement. Here you can have any kind of distance, okay? You can reach from point A to point B either through this path that is shown, or you can also reach through like kind of any other ways to reach. But the distance and displacement, these two things should not be really confused with each other. The distance doesn't always mean that it is going to be larger than the displacement. No, not at all. Like in the second example, you see that between point A and point B, the magnitude of the displacement and the distance are the same thing, okay? The main difference between the distance and displacement is the distance could be either equal or larger than the displacement. But the displacement is always the shortest one. And second, it tells the direction. Like if you move from point A to point B, this direction from point A to point B, the vector quantity, that is the displacement. Okay, let me give you another quick example. Here I'm standing, and let's say a friend asked me to move. How much move? He asked me to move 1 meter. He just said, move 1 meter. Now it is up to me to decide to move in the right side or on the left side or the forward or the backward direction. I am free to move in all directions, but since he is asking me to move 2 meters, I'm moving 2 meters. So there is no vector sense to it, okay? Because it's just the magnitude, he's giving me 2 meters. But if he says, move 2 meters to the right, then I have to move 2 meters to the right. If I move to the left, that is something I'm doing which is not he's asking me to do, okay? So this is the vector sense. Now when it comes to the origin, as I give you an example that with respect to this camera, I have some position. So in the physics language or in the mathematics, which we will be using origin. So since you have the XY axis is like this, right? So whenever you are discussing a motion, you have X and Y axis. And then here is the origin, which is the cross point of the X and Y axis. And with respect to that axis, you are defining the position of a particle P. How far that particle P is from the origin. So this is your reference point. Now, if a particle has changed its x-axis, like is in this figure here, like which is a diagram shown here, if the particle moved from its initial position, which was x1, to a next position, which was x2, then we want to determine the distance from which it has moved to the next distance. So let's say this example, here I have one-dimensional analysis, and let's say this is my origin, okay? And the particle was initially here at x1, and then later on it moved to x2. I want to say how much is this distance, okay, between this. What I will do is, I know the distance x1, let's say this is 1 meter from the origin, and the x2 is 3 meters from the origin. And this is 1 meter from the origin. So you guys can answer this. If x1 is 1 meter from the origin, and x2 is 3 meters from the origin, so what is the distance between these two?
2 meters.
2 meters.
Yeah. So the way in which you are explaining, basically, you are coming to this answer is that x2 minus x1, which is 3 minus 1 equal to 2 meters. So this is what your brain is actually doing, right? So that will be our way to determine the displacement for 1 dimension. For 2 dimensions, then there will be y component. For 3 dimensions, there will be also the z component. Displacement of minus 4 means that the object has moved towards the decreasing direction by 4 meters. And it is quite clear here. Let's say, again, this example, but let me clear this. It doesn't always mean that the object was on the negative quadrant. So here, let's say the object was here, and it has initial position x1 right there. And then x2, the last position of that was somewhere here. So the object has moved from x1 towards x2, like following this path. Okay. If the object initially here was 8 meters away from the origin, and here it is 4 meters away from origin, and when we want to determine the displacement, it is going to be again x2 minus x1. So x2 here is 4 meters, and this is 8 meters. So you know that the negative quantity is now more minus 4 meter. I'm getting the answer. So even though the particle was still on the positive quadrant side, on the positive x side, but it was just moving in the negative x-axis direction. That's why we are getting the negative sign here. Okay, so this will be our understanding for this kind of motion.
Doctor.
Yes.
If in this question ask me about the distance, so it should be just 4 without negative.
It will be just 4 because the distance doesn't make any difference. Okay. Yeah. Distance is always positive. Here is a checkpoint. It will enhance your understanding further. And I need to ask you this question here. Here are 3 pair of initial and final positions respectively along x-axis. Which pair give me a negative displacement? So all you need to assume here that the first one is x1 and the second one is x2. So which one is giving us negative?
B and C.
B and C. Okay, so you got it. Here you need to subtract just the 5 minus 3. You are going to do this. Here we are getting 8 and the last 2 are giving us negative quantity. So that's the answer for it. Now we are switching the gears. We know the distance and also we know at this point displacement. The distance is a quantity like the space between the 2 objects, but it is always positive. There is no need for direction in that. While in the displacement, there is always a sense of direction. When someone is talking about displacement, he has to talk about the magnitude of the length plus the direction. If someone is talking about the distance, he only talks about the magnitude. Okay? So when an object is moving, since we are bringing everything to motion now, I'm standing here as you are seeing me, and I'm standing at the origin. Now I want to walk towards this door. The distance between me and this door is 2 meters. Okay? The distance between me and this door is 2 meters. I cover this in 2 seconds. So a question which is a very logical question is how many, what was my speed in order to cover this? Or in other words, you can say that the distance 2 meters you have covered in 2 seconds. So what is your average speed? These are the kind of questions what a person can ask. And here we are making the judgment on that. Whenever you have a distance I covered 2 meters and in 2 seconds. And someone can ask me what is my speed? I can cancel out the 2 2's. I will get 1 meter per second. And this 1 meter per second is actually my average speed. Okay? Because what if in the first meter I was a little bit slow, and what if in the second meter I was a little bit faster? But at the end, I have covered 2 meters in 2 seconds. So therefore, when I'm averaging them out, I'm getting 1 meter per second. So when I walk, it may not necessarily be every meter I cover in every seconds, but the average is coming out to be this. So whenever we are talking about the average speed, for example, then it is again the distance divided by time. Whenever we are talking about the velocity, it is displacement divided by time. Velocity is a vector quantity and speed is not. Speed is a scalar quantity. Okay? So now the difference between the distance and displacement which we have made initially in the last slides, now we are moving that ahead to this here. Whenever you have displacement divided by the time interval, that will be velocity. Whenever you have distance divided by the time interval, that will be your speed. And here, velocity is a vector quantity and has with it an associated sense of direction. So when you are talking about the velocity, you always ask in which direction that car has moved, whether he will move to the north or to the south. When you associate the sense of direction to it, then that's the velocity.
Doctor,
Yes.
if the velocity was minus something, that's
Yeah.
mean he's moving in the left side or down.
Yeah, let's say you are standing at the origin, and object is coming from the positive x-axis towards you. Then his velocity can be negative because he's facing towards the negative x-axis. Okay.
Okay.
So here, in this diagram, which you are seeing, there is an animal. It's an armadillo, and that armadillo is moving from a distance which is -5 to the left side of the origin, and he moves towards right. So there is this line parameter here. Eh? You see the line axis. So this one-dimensional analysis here, you have the origin, which is here, the crossing point. And then on the left side, this is negative x-axis. And from here to the right, this is the positive x-axis. So the armadillo is coming from the negative x-axis towards positive. So we know for sure that his direction now, the velocity sense is towards positive x-axis. So therefore, his velocity is positive. Now, when we are recording his motion, like how fast is he going? So we are plotting the x-axis and y-axis, and you know at this point that what will be the independent quantity, what will be the dependent quantity in the language of mathematics. So independent quantity, you plot on the x-axis because the time is independent. Time runs irrespective. But the animal which covers the distance and time, that is the dependent time quantity. So you plot that on the y-axis here. Okay. When armadillo was at -5 meters to the left of the origin, you just started your stopwatch and you are observing them. So initially he was a little bit slow because more time is passing and he covers less distance. And after some time, he picks up some speed. He is speeding up and eventually reached the origin right here. So when 3 seconds were passed, he just reached the origin. And then he's still continuing his speed, but he's kind of tired now and he's slowing down. So in this region, he's again slowing. This is his fastest region. And this and the first part, these are the slowest regions. Now let's analyze his motion, how we can understand, make sense of this. Well, I'm interested in the average velocity at this point. So what would I do? I will have a straight line fit to this path in the plot x and y axis. And when I do that, I see that my best fit of the straight line, it touches the curve of his path at 2 points, here and here. And here, when you look at this location, definitely armadillo was slower than the path suggested by this straight line. And when you look at this region, definitely armadillo is faster than the speed which this straight line is suggesting. In one region it is faster, in another region it is slower. But on the average, when I'm taking it, I will be taking the final position of the armadillo, which was, you know what it is here, right? From this, like the final position is 2 meters, right? That's what I want to focus on. So if he is a 2 meter left at the final stage, minus 4, like a 2 minus -4. So you know this negative sign will make it positive. So 2 plus 4 equal to 6 meters. So the total distance he covered in this graph limits, he covered 6 meters here. In how many seconds? Well, this point is corresponding to 4 seconds, and this point corresponds to 1 second. So 4 minus 1, it gives me 3. So I will divide this distance, which is 6 meters, divide by 3 seconds. And when I get it, I get 2 meters per second. So 2 meters per second is his average speed. And it is also very clear, like since I know that there is a lot of craze about the playing soccer. So you know that, let's say, Barcelona do some 5 goals in one half, and then in the second half, Barcelona did 3 goals. And if someone asks you, what is his average number of goals in each period or in each half, then you add 5 goals with the 3 goals. So in total, you got 8 goals, and you divide it by 2 halves. So 8 divided by 2, you say, on the average, Barcelona did 4 goals in each half. So this is the same story which we are doing. And so like the Barcelona didn't do 4 goals in each half. In one, it was higher, in another one, it was lower, but the average is 4. Similarly, the speed, when we are determining the speed, in each passing duration of time, the speed may not be the same. But when we comes out to the average, that's what we are concerned about.
Doctor,
Yes.
can I choose another point to?
Okay.
Because can you go back?
Okay.
Because if I choose the point 3,
Yeah.
and let me see, and -5 and 0 on the
Yeah,
x-axis.
yeah.
It will not be the same answer.
It will be the same, but you need to be careful a little bit. First of all, whenever we are talking about here, we are talking about the best fit. Okay. The best fit means that when you are taking the 0.3 and 0.5 and you put the straight line, you are not just touching the 0.5 here and 0.5 here, and the entire line is below, like the entire path is below the straight line. If that is the case, then it means that the fit you applied is not a straight line, not your best fit. Okay. But if when you are doing this, you need to lower it down, for example, this point and this point. Okay. So that half of the path approximately is above the line and half of the path approximately is below the line. So that will be your best fit. You got the point?
Oh, okay, got it.
Yeah. Yeah. Okay, so average speed is nothing more than what we discussed for the average velocity. But here I said it. Let me give you one example, and here you look at the whiteboard. Okay, this example will clear everything. Here I have point A, and here I have point B. I move to point A to point B. From point A to point B. Then from point B back to point A. Okay? This is path 1, and this is path 2. At the end of my journey, I was at point A. Let's say the distance between point A and point B is 1 meter. If I ask you how much distance have you covered, what will be your answer?
0.
2 meter.
2.
Yeah, the distance you have covered, it is 2 meters. Okay. And therefore, when you are dividing them, getting the average velocity, let's say you have covered this in 1 second and you have covered back also in 1 second. So the average speed, the average speed will be 2 meters divided by 2 seconds. So it is 1 meter per second. That's what you get. But when I ask you about the displacement in the complete journey, how much is your displacement?
0.
So your displacement is 0 because you have a vector A, let's say AB. AB was your vector in one direction, and then you added with another vector which was AB, but now it is negative. So when you do this, you get the 0 vector. So the sum of the two vectors is already 0. So when you are looking for the velocity, average velocity, it is 0 displacement divided by 2 seconds, which gives you 0. So this is what is the difference between average speed and average velocity. You need to look for the initial point and the final point in your journey. And this is more related to this example here. You drive a beat up pickup truck along a straight road for 8.4 kilometers at 70 kilometers per hour, at which point the truck runs out of gasoline and stops. Over the next 30 minutes, you walk another 2 kilometers farther along the road to a gasoline station. What is your overall displacement from the beginning of your drive to your arrival at the gas station? How much is your displacement now? Assuming that the entire path
10.
is a straight path. How much?
10.4. 10.4.
10.4. Yeah, assuming that the path is a straight path, because they are saying it along a straight road, right? So therefore, you have the total displacement 8.4 plus 2. So it gives you 10.4 kilometer direction. So since this is the one directional, so therefore it is a displacement. And you are assigning the vector quantity to it, like the direction from the home to the gasoline. Second part is, please turn off your microphone, guys. What is the time interval T from the beginning of your drive to the arrival of at the gas station? So how much time have you spent? Well, in this, we know it is half an hour, right? For the last part, we know the T2 is 30 minutes, which can be translated as 0.5 hour. But for the first part, we don't know. All we know is that the speed is distance divided by time. So from here, when I multiply both sides with T and divide by V, I will get D divided by V. So the distance it has covered, it was 8.4. And the time, the speed was 70. So it gives me the T1 interval. And let's see how much that is.
0.12.
Yeah, 0.12 hour. This is one interval, this is another interval. So the total time when I'm looking for, I will need to add them, right? As it is added in the slide here. So this time plus this time, it is 0.62 hours. This is the total time interval. In the last, in the part C, what is your average velocity from the beginning of your drive to the arrival to the station? Find the both numerically and graphically. So what we need to do is to determine the velocity. We know it was a straight path. The guy just went in one direction. So all I need to do is to take total displacement, which was 10.4, divided by the total time interval, which was 0.5 plus 0.12. So it is giving me the total velocity here. As it is displayed here, what you see. Graphically, the graph is given here, okay? I don't need to go into the details of the graph. You can see it in the slides. If you have any question, ask me. But the last part, suppose that suppose that to pump the gasoline, pay for it, and walk back to the truck takes you another 45 minutes. So when we are talking in the terms of the hours, T3 is equal to 0.75 hour, right? 0.75 hour or 3/4. What is your average speed from the beginning of your drive to the return to the truck? So here is the thing. Now we are talking about the average speed. So for the average speed, we are talking about the total distance, right? So the total distance when this guy was going from his house to the gasoline station, the total distance he has covered, it was 10.4. But then he covered again 2 kilometers from the gasoline station to the truck. So the total distance he has covered 10.4 plus 2. In total 12.4, which is given here. How much time he has spent? Well, on the one way we already had calculated the total time. On the way back, they have given us 45 minutes. So we need to add this time to the total time as well. So the total distance divided by total time is giving us the average speed for the person. Now, what if it was asked about the velocity? What will be our answer then? Instead of the average speed, if it was asked for the velocity, what will be our answer?
The same of the last question.
Yeah, so like how much now currently, how much displacement when we have when the guy come back to his truck?
8 kilometers.
8.4.
8.4, because initially that guy has covered a distance 8.4 kilometers from his house to when the car was broken, and from the broken truck to the gasoline, and back from the gasoline to the truck. So the distance which is completely covered and cancelled out, it is not this distance, while this distance, right? So quite rightfully when this student said it is the 8.4 is the displacement now, and the time we need to add all of the time. Like the time when you are dividing it, it will be the total time, 1.37 hours. So the velocity will be accordingly. Okay, so I think the time is up, guys. Right? What is the time?
52 minutes.
52, okay. So we can stop here. Next time I will go, in the next lecture, I will go over the instantaneous velocity and instantaneous speed, and then to the acceleration. For those students who need the attendance, I can open the sheet for you just today. It should not be the case every day, okay? Ahmad Abdullah Bawazir, why you are looking for